Hello, and welcome to Math Analysis or Pre-Calc. Currently we're in section 7.2, or we're going to start 7.2, and this is going to be talking about the sum and difference formulas, or addition and subtraction formulas. And on the sheet that I've provided for you, the sum and difference formulas, or the addition and subtraction formulas, are the ones down on this first column here. So we have that the sign of, if you take two angles and you want to add them inside that sine function, we can break it up, but it becomes a little bit more complicated. We have to do this whole piece. So these formulas are what has to happen in order to do this. We can't just simply distribute the sine function through. We've never been able to do that with any functions that we know of. Our square root function doesn't work. Exponentials and logs did not work. So we have these complicated formulas that are here. And we're going to learn some methods to help us understand these a little bit more in depth, and some of the applications that are out there. Now, some of these applications are very dated, and to be honest, we would never do them in today's world, but the reason we do them is to help us understand the formulas themselves. So the first type of problems are those of the ones that I meant. We would never do this today, is to evaluate the tangent of 195 degrees. Exactly. In other words, we're going to use and creatively write 195 degrees in terms of angles that we know. And we know the 30, the 60s, the 45s from our two special triangles, that 30, 60, 90, the 45, 45, 90. And all the multiples around. So we've learned how to deal with the sines and cosines of those. So what we're going to do is creatively write 195 degrees in terms of angles that we know. And this takes a little bit to sometimes hit the right one. And in fact, I'm going to do this one two different ways because I want to go through two different formulas. And I notice through practice is that 195 is the same as this 150 degrees plus 45 degrees. So that's what I'm going to do, is I'm going to rewrite this as the sum of these two angles. And then I'm going to go through and calculate, the formula here. So I'm going to just substitute the alpha being my 150 and the beta being my 45. I'm going to substitute those into this equation that I have. So this is going to be the tangent of 150 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 150 and the tangent of 45. And now 150 and 45 are triangles that we know. So I'm going to remind us what they look like. 150 degrees is in that second quadrant, where this is our 30-degree reference angle. And that's a triangle we know. That's our 1, 2, square root of 3. 1, 2, square root of 3, that being negative. The tangent would be this opposite over adjacent. So that's going to be this guy. And then we're going to have to add to that the tangent of 45. I'm going to draw the 45 in here, our 45-degree angle. And that's a 1, 1 square root of 2. And the tangent would be 1. Now substituting in the bottom, this is going to be 1 over that square root of 3 negative. And these are multiplied here. And now what I'm going to do is clean this up a little bit because I have a complex fraction. So what I'm going to do is I'm going to combine these. I might actually rationalize this so I don't have to try to get square roots and all that sort of thing. So this is going to be that negative square root of 3 over 3 plus 1. And here I'm going to do some of a multiplication. That negative times a negative is a positive. And here I'm going to have that 1, it would be a plus square root of 3 over 3. Combining and getting common denominators, I'm going to write this as 3 over 3. So this would be a negative square root of 3 plus 3 all over 3, all over, and again, common denominator. Inverting and multiplying, those 3's cancel, and I'm going to rearrange the order there. So 3 minus the square root of 3 all over 3 plus the square root of 3. And we could rationalize again. I'm not going to spend the time to go and rationalize my denominator again, but in order to do so, we'd have to multiply both top and bottom by that conjugate of this piece. That is something that you should be able to do, so you should be able to actually go further, but I'm not going to do that in this video, because in this video we are stressing how to use these formulas. And so I want to show you that, you know, how to do that. I don't want to spend a lot of time making it look pretty. So I said I was going to do this one twice. And the other way I'm going to write that is I'm going to realize that 195 I could have written also as 225 minus 30. So I could write this then as the tangent of 225 degrees minus my 30 degrees. And now going into my difference formula, and I'm pulling this right off the sheet. This is going to be the tangent of 225 degrees minus the tangent of 30 degrees all over 1 plus tangent 225 times the tangent 30. And those should be little degree symbols in there. All right. Now we need two different triangles. We need that 225 degrees. 225 is in the third quadrant with a reference triangle of 45 degrees, which is a 1, 1 square root of 2, but those are both negative, square root of 2. 30 degrees is in the first quadrant, and that's a 1, 2 square root of 3. And now I can pull in my numbers. Tangent of 225 is a negative 1 over negative 1, or 1. This would be minus tangent of 30 is 1 over that square root of 3. And here we're going to get 1 plus tangent, and this will be 1 and 1 over the square root of 3. And if you look at this compared to what we had before, they're the exact same thing. Obviously, we wrote the numerator in the other order, but everything turned out, I mean, our negative negative became our positive, but we're getting the exact same values. So no matter how we write this, we will see the same thing. It is possible that when you do these problems, if you pick different angles, you might get something that looks different, but numerically is the same. So just kind of be aware of that. All right, let's do another one. And let's pick the sign of pi over 12. All right, so we're going to try to somehow creatively write pi over 12 as either the sum or difference of angles that we know. Now, pi over 12 is going to be, trying to think, we might need to convert it into degrees so we can see what it is. So if you remember how to do that, pi over 12 times 180 over pi. And I need my calculator. I get 15 degrees. And now I need to figure out 15 degrees, a way to write 15 degrees. I could think of that as 45 minus 30. Okay, but in terms of radians, 45 is your pi over 4 minus a pi over 6 in terms of radians. Now I have the difference, and we're doing a sine, so the sine for the difference is going to be the sine of that first angle times the cosine of the second angle minus the cosine of the first angle sine of the second angle. All right, and I need my two little triangles. I need my 45, or my pi over 4, which is 1 square root of 2. And I can't really draw these on the same picture because they're in the same quadrant. So my pi over 6, that's my 30. My 1, 2, square root of 3. So the sine of pi over 4, that's this one. That's 1 over the square root of 2. Cosine of pi over 6, that's going to be the square root of 3 over 2 minus cosine 1 over the square root of 2. The sine is 1/2. Multiplying here, I get the square root of 3, and I'm not going to rationalize this one because I believe you guys could if you needed to, but combining square root of 3 minus 1 over 2 roots of 2, and you could rationalize if needed. Okay, but again, in this video, I'm more concerned about making sure we can get the values figured out and seeing how that formula works in order to solve this. Okay, I'm going to do one more, I think. Oops, it's not the one I wanted. Sorry about that. And let's do the cosine of 75, and I'll write it in terms of degrees. Not that it matters. We should be able to do both. 75 degrees in terms of writing that's 45 plus 30. So I'm going to write this as the cosine of 45 degrees plus 30 degrees. And it does not matter if I write it as 30 degrees plus 45, which one comes first. It does not matter. You will get the same result either way. Now the formula for this is the cosine of 45. You'll notice that it's cosine, cosine, and then sine, sine, and the sine in the middle. Whoops, and I'm going to run out of room here. Is opposite. And you guys get to use the sheet. In my day, we did not. I should have kept my 45, 45, 90. 1 square root of 2. 1, 2 square root of 3. So that's my 30. Cosine of 45 is 1 over that square root of 2. Cosine of 30, square root of 3 over 2. Then we're going to minus the sine of 45, 1 over that square root of 2. The sine of 30. Wow, this looks very familiar. It is exactly the same as before, and that should not bother you much, because in the previous problem we did a 15 degrees, right? Well, if we were in a right triangle, and that was the 75, the sine of 15 is this guy over this guy. Well, the cosine of 75 is that over that. So it shouldn't surprise you that we get the same result of the sine of 15 degrees and the cosine of 75. Kind of wanted to do that to see if you guys recognized it. I'm going to stop this video and come back with some more examples so we can see other problems that we're going to be seeing with these new identities.